be giving a lecture to us on the basic air conditioning and the application นะคะ but before that, let me share my screen about our course syllabus นะคะ before คุณอุทัย lecture let me talk about previous class and today's class as well as next lecture นะคะ students let me share my screen a little bit นะคะ before คุณอุทัย let me share my screen my desktop now okay this is our course syllabus นะคะ and okay so actually I hope everyone sees my screen yeah last week we had a lecture on building materials นะคะ as well as some heat transfer and green building performance นะคะ and I ask you to join our webinar as a homework นะคะ and today instead of a field trip นะคะ I have invited our guest lecturer before that you see we have introduction to heat transfer and concept of OTTV how is the law and regulation permit us to have a limited heat transfer from external into the building and we have learned about the wall materials roof materials and today we are going to have HVAC like how we can think about air conditioning and as well as the application in the building นะคะ so let me stop my screen sharing and I would like to invite คุณอุทัยนะคะ he's the expert in air conditioning and also air quality system นะคะ perhaps คุณอุทัยคะ over to you may you please introduce yourself in a more details ค่ะ what's your background what you are doing and also today's brief lecture ค่ะ คุณอุทัย over to you ค่ะ thank you very much
thank you Dr. Asharawan นะครับ actually my English is not that great but I will try my best to explain you about the thermal comfort and the air conditioning. I would like to share the screen a bit.
Please introduce yourself a little bit.
Yeah,
okay.
my name is Uthai Lohachitranon. Actually, 15 days ago is the celebration that I have started my work 30 years ago in the air conditioning company, one of the earliest producer in the world. I started at York International in 1991, working in the large tonnage chillers selling and project sales, and also have the I working as the employee for 24 years, and working and the last position is the managing director and country GM of the Johnson Controls in 2015. Okay, so then after that I start my own business, and currently I'm the director of the Upstart International, which is the importing the large tonnage chillers, variable speed drive, special air handling unit, and also all kind of the CPMS, which is we call is the building automation system or chiller plant automation system. I have experience to help the society in Thailand in terms of the currently I'm the foreign committee of the ACAT. ACAT is one of the important society in Thailand, which is they are the key air conditioning association of Thailand, which is doing mainly training the people who are working in the air conditioning business, not only for designer, contractor, and also the supplier. I also has been president for since 2018 up to 2020 as the president of ASHRAE Thailand chapter. I think student has learned a lot about the standard which is mainly mentioned many times. It is the ASHRAE. ASHRAE is the American Society of Heating and Air Conditioning Engineers. They are start 100 over years ago, 120 over years ago, which is they gathering and helping each other to build the standard of the air conditioning. And later on, they are including the building envelope, and they're talking about the energy rating also. So they, for the last 20, 30 years, they involve a lot of architects, and not only engineers or mechanical engineers, but also the architects and energy engineer also. So I graduated from Chulalongkorn University in 1991, and I have a master's degree from ABAC, which is the Assumption University at the moment. So that's all about me. So shall we start
Yes,
to talk?
please.
Yeah, okay. So today we were talking about 4 topics. I will use around 2.5 hours. All right. So if you have any questions, students, please stop me anytime. And if you are interested in this kind of subject, you can explore. They have a lot of information in YouTube today about the air conditioning, and also the standard that we are talking about today. All right. So first, I think you all know that currently the air conditioning is one of the major things in nowadays. All right, we cannot live without the air conditioning. Actually, the air conditioning is the process of moving the heat and controlling the humidity, as well as the removing the dust. In some cases, they are air within the building and vehicle to achieve the more comfortable interior environment. And you can read all of this, and then of course in Thailand we have ventilative cooling and also the passive cooling, right? So if you are interested, you can look at in the Wikipedia, which is I have shared in the bottom of this page, right? So I can say that the air conditioning has been, I think, produced and invented long ago, right? And the first person who has introduced to control temperature and humidity is Dr. Willis Carrier. All right, so that is the first commercialized unit that we are known as the modern air conditioning. Right. In the picture, you can see on the left-hand side, this is the household in 1937. I think it's about almost 100 years ago. All right. This is the unitary aircon in the household in US. Currently, we all know that we mostly use the split type in the household. Okay. I will talk about more in the later part of the presentation and lecture. First, I will talk about the air conditioning principle. I think I think I look at the curriculum that Dr. Ashrawan sharing. I think you have learned something already, but I just repeat it again. So the basic principle of refrigeration is the key for the air conditioning. Refrigeration cycle is the important principle that we need to learn about the air conditioning system. So we will talk about the sensible heat. What is the sensible heat? The sensible heat is the heat which is the change in the temperature. Let's say if the temperature is increasing or reducing, it is the sensible heat. This is what we mean on the sensible heat. Sensible, it means we can sense it, so we can see the temperature difference. Latent heat, you can see in the picture that the 32 Fahrenheit ice, it can melt into the liquid, okay, in the liquid form at the same degree. What makes this change the I mean the phase of the from ice to liquid? It is heat, but it not change any temperature, so we call it latent. Latent heat is nothing change in terms of the temperature. It's exactly the same as the boiling water. The boiling water we talk about 212 Fahrenheit or 100 degrees Celsius. Okay, in the air conditioning, most of the pioneer in this field, they are using the imperial unit, which is the retrieved from USA. So bear with me when I'm in the school, when I'm in the university, learning all is in metric, in Celsius, in joules, in kilowatts. But when you come to the air conditioning, mostly they will talk about BTU, ton, Fahrenheit, yeah, pounds, pounds per square inch, or something like this. Okay. If you pouring the alcohol on your hand, it will evaporate, and you feel cool. Why? Because it absorbs the heat from your hands and evaporate together, and they change the phase of the alcohol and it boil. And when boil, it's boiled by the heat in your hand. So this is the we call it evaporates. All right. This one you can see that when we talk about the refrigerant, okay, refrigerant, actually they have so many refrigerant in the market, including water. You may interesting. Sometimes when we talk about refrigerant, they talk about the refrigerant R11, R123, R134A, or R22. Okay. Actually, this coming Friday, they have a free webinar of the ASHRAE Thailand chapter. Young engineer Kun Patana, he will have the free webinar on the updated refrigeration. All right. So this one we talk about the refrigerant also. If you're interested, I will drop information to Dr. Ansharawan. All right. So you can see in each refrigerant, they have a different pressure, working pressure. So it will have a different boiling point also, and they will have a different pressure inside the vessel, right? So what is required to make a refrigeration unit? Okay, what they need, the first one is a compressor. Compressor, what we need to build from to build the pressure from the low gas. Okay, the low pressure gas, and when they compress, there will be a high pressure gas. Second one is condenser. When you produce the high pressure gas, they have some heat, which is you need to condense the high pressure gas into the liquid high pressure high pressure. After that, they need the expansion device or the metering device to reduce dramatically pressure, to let the pressure very low. So when the refrigerant go into the evaporator, it can be absorbed because of the pressure has been reduced a lot in expansion device. It can come down up until you use the air in the room to boil the refrigerant in evaporator. So it absorbs the heat from the room and then go back to compressor again. So the gas will be pumped back to the compressor. Okay. So refrigerant is inside the pipe. I will show you the system. So this is a compressor. Compressor, you can see that this is a condenser. This is expansion valve, and this is the evaporator. The cycle is like this. When the compressor is built, the gas, the low pressure gas into high pressure gas, then it will through condenser. It will use this latent heat out. Okay, so when the condenser reject the heat out of the high pressure gas, it will become a high pressure liquid. Okay, when the high pressure liquid go to the expansion valve, it will be reduce the pressure. Okay, when it pass the expansion valve, it will be the low pressure liquid. When the low pressure liquid pass the evaporator, they will they will absorb the heat in the room. All right. When they absorb the heat in the room, the liquid low pressure will evaporate. We call it evaporator, is evaporate into the gas. Okay, and it will be back on the compressor again. So this is quite simple. All right. If you are not understand this at the moment, never mind. You can go to the YouTube, which is the talking about refrigeration system. It can show you and have more animated on this. But in actual fact, the condenser and evaporator, it will try to absorb the heat and reject the heat and changing the phase of refrigerant. Let's say from condenser, they will change the gas, high pressure gas into liquid high pressure. Or the evaporator, this one, they use the low pressure liquid. All right, low pressure liquid, they can absorb heat easily. It's like the alcohol to absorb the heat from the hands, and it can be evaporated and will be a gas from the liquid to be a gas by using the heat in the evaporator. All right, so this is the high pressure side, and this is a low pressure. So this one is a cold refrigerant liquid. Okay. Okay. To be easier to see, to visualize this, you can see this. The compressor will look like this, and the condenser will have the air cool. This one is an air cool condenser, and expansion valve device actually is like the piping, which is to reduce the pressure, and evaporator is the coil. This is the basic refrigeration system, which is the same as the previous one. Okay, so this one will show you more graphically on. So this one, you can see the suction line. They will have the gas, okay, gas, and then they pressure up by the compressor. So from this chart line, there will be the high pressure gas with the heat, and then they will condense in the condenser, and then come down to be the liquid high pressure, and then come down to the liquid line. After the expansion device, it will expand the refrigerant into the low pressure liquid. When the low pressure liquid absorb the heat from the room in evaporator, will be come back to the suction line again. You may see this is the enthalpy chart. You will see this more and more about the air. If you learn more about the air conditioning, this one is the most important. We call it pH diagram. P is the pressure, H is the enthalpy. Enthalpy is the energy, right? So this line is the liquid line. So anything beyond this line in the left-hand side will be liquid. Okay, this is a liquid line. This is a vapor line. So anything beyond this will be vapor. So in between, it will be in between these two lines, it will be liquid or vapor mix, right? So in the evaporator, from the low pressure, this one is a pressure, right? So the low pressure liquid come to the evaporator and it will be fully evaporate. So this one will be vapor, low pressure. Then it will boost the pressure by the compressor. The compressor will be increased the pressure. And then they will be reduced. No, they will have reject the heat, okay, by using the condenser, okay, from vapor down to the liquid vapor mix and down to the liquid line. After this, they will drop the pressure by using the expansion device. So this is the pH diagram of the simple air conditioning system. Okay, refrigerant will absorb the heat from the load. All right, and this one, refrigerant will reject the heat to the atmosphere. Okay. Okay. The principle has been done in the first topics. Any question from student? Or so far so good? Okay, so no question. So I go to the topic 2, the human comfort. Everybody, when I think everybody have the mobile phone when they look into this slide, you can see that the temperature, right? Okay, temperature, it will show you that this is the forecast temperature, right? This is this is the temperature yesterday. So the temperature now, okay, 30 degree, okay. What they show that, okay, they have humidity 77%, okay. They have a wind, but you can see the feeling of this is 37. Why is higher than 30? Okay, so this one, if you have experience on this, you will have some question why they have feeling more than the temperature that's shown in the forecast. Okay, they have 6 factors of the human comfort, right? So first one is the air temperature. So the air temperature is the temperature of the air surrounding the body. Okay, the air surrounding the body is usually given in the degree of the Celsius. Okay, so most of the time the EGAT การไฟฟ้าฝ่ายผลิต always say that 25 degrees Celsius is the best to set the room temperature. Okay, that's only one part, but actually they did not say anything about the percent of the relative humidity or the humidity in the room. So basically the air conditioning that you have bought in the market, they will create the temperature. If you set at 25 degrees Celsius, the humidity will be around 55 to 60% of the humidity, if the relative humidity. Okay, so the air temperature is the first factor on the human comfort. Okay, second, radiant temperature. The radiant temperature has greater influence than the air temperature. Okay, for example, that you have a heat source. Okay, when you have air around you is like 25 degrees, but you expose yourself to the sun, or you are next to the electric fire or or the wall, which is have heat, or the rice cooker or dryer or the hot surface. Okay, so this one will have more influence than the air temperature. So this one is one of the heat source also. So this one we call is radiant temperature. Okay. The third one is the air velocity. The air velocity, this one is describe the speed of the air moving across the people. So if you have the air moving around you, sometimes the temperature is not so low, you feel comfortable. All right. So the fourth one is humidity. Humidity is the relative humidity is the ratio between the actual water or the vapor in the air. So sometime when you feel, okay, we back to this. When you back to this, the temperature on the uh, uh, Bangkok 30 degree, but humidity is 70%. It makes you feel not so comfortable. All right. So this one is talking about the humidity. So the humidity is the major part to make you feel comfort or not also. Okay. And personal factor. Okay, we have another two personal factor. The first one is the clothing insulation. If you are having t-shirt in the summer, I think it should be all right. So it's not the thermal comfort very much depends upon the insulation effect on the clothing that you are wearing. All right. And the second one is the work rate or the metabolic heat. Okay. So in the physical work, if you are working or you are learning, the metabolism or the heat that we produce from your body is not so high. So it will make you more comfort rather than just when you are working or you do workout, you are playing basketball or doing some activities, then you have more, you have less comfort in terms of the metabolic heat. Okay, so this is a sixth factor that is that impacts in your the human comfort. Okay, so back to this, they have three charts that I would like to introduce to you guys. That first is the ASHRAE comfort zone. This is based on the ASHRAE standard 55. Okay, so sometimes the temperature, let's say 25 degrees Celsius, but you feel not very comfort. Let's say it's so humid. Okay, when you are so humid, let's say 100%. This one is a humidity ratio. You see, this is a graph of the humidity ratio is going up like this: 10%, 20%, 30%, up to 100%. Okay, the chart. This is the chart that they have done the research. Okay, uh, the red one, no, the red one, the shading red one, it is the human comfort for the summer, and the blue one is the comfort in the winter. This has been done long ago. Okay, and it has been improved year on year. Okay, every 3 years, ASHRAE will change the update the standard. Okay, so let's say in Thailand we have 25 degree only. Okay, let's say as the EGAT said, oh, 25 degree is the best for the energy consumption, energy conservation. So is that make you comfort? Not really. Okay, if the 25 degrees Celsius and it is in between this percentage of relative humidity up to how much? Up to 70 or less than 7. Okay, less than 60% relative humidity, you still feel comfortable. And anything beyond this, anything beyond 60%, the 25 degree may not feel comfort to you. Okay, so this is the comfort chart, comfort zone that you can use. Okay, this one is a dry bulb. This is the dew point, and this is the humidity ratio. So this one is very important chart, especially you are the architect and the designer. So this one, it will play an important part in the design criteria. Okay, this one not only ASHRAE but also in similar way of the measure. The ISO 7730 is the another reference that they have based. Okay, so the data based on ISO 7730, okay, and the ASHRAE standard 55. So this one is a chart of the comfort. Okay, the second one, okay, we're talking about the temperature and the airspeed. Okay, the y-axis is the airspeed, meter per second, and x-axis is the operative temperature, degree Celsius. Okay, in this chart, okay, you can see that this one, in the right hand side, sometimes people, they are talking about the FPM. FPM is the foot per minute, and up here is also the Fahrenheit. Okay, so they have a chart which is very useful. Okay, let's say we talk about 25 degree. Okay, 25 degrees Celsius. If the airspeed is below, if the airspeed in the red shading, it is too hot. So the airspeed have to be higher than 0.2 meter per second or 0.3, let's say. Okay. The green one is a comfortable zone. Okay. The blue one is too cold. Okay. The yellow one is too drafty. Okay. It's not comfort. So the green one is the comfort zone. So this is how we use this chart for the chart of comfort of the airspeed and temperature. Okay. This one also important. Okay, especially in Thailand or in the tropical area, Thailand, Malaysia, Singapore, Cambodia, Burma, Laos, Vietnam, Indonesia. You have to understand this, the optimum relative humidity range of the human comfort and health. Okay, so temperature is not only one parameter that we are looking at. We have to look into the humidity, especially in Thailand. Sometimes you can see the molds, the molds has been growing very fast in the building. Okay, especially in the duct work. I have seen with my own eyes many buildings in Thailand, even in hospital. So I will not share you where is it, but it happens. Okay, so the temperature is not only one factor that helps you to make the comfort, but also it helps you to stop the growing of the bacteria, virus, fungi, mites, infection in the respiratory or the allergy. Okay, so you can see that anything in between 30 to 60, 30 in Thailand is very difficult to do it. Okay, so I can see mostly around 45 to 65 most of the time. Okay, but this one is a healthy zone. So anything that you can make the room not too dry and not too moist, it will help the comfort and also the quality of the air in the buildings. Okay, this one, it creates a lot of building sick syndrome in many buildings in Thailand also. Okay, sometimes you feel allergic. Why is allergic? So maybe it's too moist or maybe it's too dry in that places. Okay. Any question
I
so
have
far?
a question ค่ะอาจารย์
Oh,
how the
scare.
architect can make the building not too dry and not too moist คะ as an architect, how can they do?
You have to sit down and let the work through the M&E designer, let them ensure that the calculation is not, sometimes when you, most of the time, when we design the air conditioning in the building, they always over design. When you over design in every aspect, is too, it will be too moist in the building. Okay, and to make sure that not, and to make sure that no leaking from the outside. Okay, sorry to say, most of the cases in Thailand, the moisture is come from the leaking. The leaking we call infiltration from the crack of the buildings, from the unintentionally ventilation or not treated air before it takes in the building. So when you would like to do the dry building, you need to put some. I will show you later on. It is the dedicated outside air system we call DUAS, or the fresh air unit. Currently, is designer in Thailand. They are more and more popular on this to use this in the building. Okay. Did I answer your question?
Yeah, thank you very much ค่ะ
โอเคครับ The third one is a cooling load component. Okay, it is a bit. I think my presentation is quite fast now, so maybe I go it slowly. Okay, please have a look into the picture first. This is a typical office. Okay, the typical office, they have room inside. Okay, and we have an architect sitting down there and designing something, and we have the lights, have a people, we have equipment, we have floor, we have the walls, we have a glass, and we have the roof. Okay, and we have the partition wall. So this is a cooling load component. Okay, and this we have a solar, we have a sun. Before,
From your experience, what is the maximum, what is the most critical part that the architect should be aware of for the cooling load? What components can you please advise?
Try not to use rule of thumb. The first one, sometimes people, we are just simply say that, oh, this room we can use the 600 BTU per square meter. This room we cannot use, we use 1000 BTU square meter. Okay, so to be able to okay, you can have that kind of rule of thumb if you don't have anything on hand, right? But you have to be carefully used, and you have to have some experience also to that you have some experience whereby you have make sure that you can use it effectively. But for the designer, which is no experience, I believe they should do a real calculation of the cooling load. Okay, the cooling load of the always deal mainly from the outside and the inside load. Okay, the outside load is the most critical. They have three part, which is the most critical. Is the okay, the first is the sun. Okay, they will radiate directly through the glass. Okay, secondly is the like infiltration. They are not only bring the air inside through the leak of the glasses, but also it will bring the moist inside. Okay, this heat with moist, the heating moist, so it is the load, a lot of load. Okay. Secondly is the roof and the wall. Okay, roof and wall we have to design it with the good insulation. Most of the time in Thailand they are using some material which is not insulate or not good enough for insulation for the heat because it's very hot in Thailand. Okay, the load inside is normal. People is easy. If the adult, I can say that one person is 700 BTU. Okay, uh, and equipment we can use like 1.5 watts per square feet or something like that. I think the critical is the infiltration, ventilation, and all the walls that we have select when we design. That we have to be careful on the insulation or the heat transfer between the roof or the walls also. Okay. Okay, back to very basic. I think you all know that when we measuring the heat quantity, uh, many people they not understand what is the 1 BTU. What is one BTU? The 1 BTU is the water 1 pound, 1 pound of the water increasing 1 degree of Fahrenheit. We call it 1 BTU. Okay, BTU is British thermal unit. Okay, but I went to UK. They didn't use BTU anymore. They all use metric already. Only US side they still using BTU. Okay, so okay, if we are used to the metric, okay, me too. So 1 kilo of the water, so 1 liter of the water, okay, when they increase 1 degree of Celsius, it will equal 4.2 or 4.19 kilojoules or 1 calorie. Okay, this is the heat quantity. Okay. Sensible heat and latent heat. I already talked in the previous slides that the sensible heat is when when the temperature is changed. Okay, this one we call sensible heat. But if uh, the temperature is not changed, but the the substance has changed the phase from the liquid into the gas, we call it latent heat. Okay, from the boiling water 100 degrees Celsius is boiling. This one is latent heat. Okay, so the cooling component is this. Okay, Dr. Achalawan said that what is the criteria? I think this one can answer this. Okay, so you can see that they have cooling load components, which is conducting the heat through the roofs, conducting the heat through the walls, through the windows and the skylights. Okay, this one will do the sensible heat. Mostly will make the temperature rising, and this one is we call it the space load. Okay, the space load it also impact directly to the coil load. Okay, coil load is the coil in the air conditioning. Okay. Second one is solar radiation through the windows and the skylight. This one is also sensible load, so it will create the temperature rise. Okay, conduction. Okay, through the ceiling and the interior partition, walls and floors. Okay, this one is also the sensible load. But okay, when you look into the people they have not only sensible but also they have a latent, because when you are breathing or you have sweating, yeah, they have humidity, so they are not only have the sensible load but also they have a latent load. Okay, the light is only the sensible load. Okay, equipment and appliance, they also can be sensible and latent. Okay, and this is a space load and also the coil load. Okay, Infiltration. This is the leakage from the doors or the windows, okay, or the leakage, the crack of the walls. Also, we call it infiltration, okay, and ventilation. Okay, ventilation is you can see that infiltration and ventilation. I told you, I told Dr. Charawan just now that this is the important, which is that we have to treat this infiltration and ventilation, not only sensible but also the latent also. Okay, and system heat gain. Okay.
เดี๋ยวก่อนนะ space load what is space load again นะคะ I didn't quite follow.
A space load is the load that they have in the space. Space load.
Or you mean the equipment and the people? No.
Yes.
อะไรอย่างนี้อ๋อค่ะ
Ventilation is forcing the forcing the aircon. That one can be controlled, but infiltration you cannot control. It's leaking through the doors and the windows. Okay, ครับ this one has been the cooling component. This one, I think I will talk in general. I will not going into the too much details, but you have to understand a bit the conceptual. Okay, we need to do the AC load estimation. Okay, to why we need the load estimation, because when you do the load estimation, you can determine the airflow and the size of the air system, especially the diffuser or duct work. Okay, and you have to size the coil as per the HVAC and R equipment or the air handling unit, okay, or the air conditioning. And also this one can be provide the information to the energy calculation or the analysis. Okay, so the air conditioning load estimation is the important part that most of the designer have to do it properly. Okay, I can see many hospital not well designed, so it designed the airflow wrongly, and the result is all the operation rooms ห้องผ่าตัด get mold มีเชื้อราขึ้นเต็มไปหมดเลย so they all mold and they have to kill it. Very difficult. Okay, so it has been many cases in Thailand. Okay, the calculation method, they have plenty of the calculation method. Okay, since the 1967 up to current one. Okay, so the latest one, mostly they use the computer. Okay. Okay, the major step on the load estimation, you have to determine the indoor and outdoor design condition. Okay, estimate the thermal properties for the envelope components. Okay, determine zoning, space, and performing the area for takeoffs, and the estimate space sensible and latent loads. The sensible and latent load the sensible load will help you to design the flow, the airflow of the rooms. Okay, determine the fresh air requirement. This one will be in accordance to the ASHRAE standard 62.1. Okay, and the calculation load, coil load. This one is just the load that you have to calculate enough to ensure the coil is performing. The project information, where is the site location? Sometimes I don't know, maybe our student in the future, they have to go and design the location outside Thailand, maybe in the cold weather or in the hot weather, or the same as the tropical area in Thailand. What is the surrounding condition? The orientation of the buildings, as you can see that if you're in the northern okay, the above part of the world, it will have an impact on the load of the heating load in the buildings also. Okay, what kind of the use in the buildings and the spaces. Okay, physical dimension of the building and spaces. Okay, ceiling height, columns and beams, construction material, roof, walls, windows, doors. Okay, people, the numbers of the people, density, how many people per square meter. Okay, how many people per 100 square meter, duration of occupancy in the morning, in the daytime, in the evening, and what kind of the nature activities that they have in the building. Okay, the lights. Okay, the lights for activities in the office, or the lights of the activities in the hallway, or the operation room, or operation theater, or the theater, or so the lighting for different rooms and application will have a different specification. Appliance, okay, ventilation, and continuous intermittent operation, and also the local regulation and codes that we were talking about. Okay, project policy. Okay, this is the project information that you need. Cooling load component. Okay, in Thailand we have the พรบควบคุมอาคารปี 2522. Okay, so they also have the energy conservation law in 1992. Okay, and OTTV. I think you have learned already. I believe. Okay, am I right, Dr. Ashravan?
Yes, we have learned that, and I have just announced about the new regulation that has been accepted. I mean, announced on March the 13th, about the
March the
new
13th.
OTTV and
This year ใช่ไหมครับ
this year,
Oh, okay.
I actually was the one who helped on this new regulation under the Association of
Oh,
Ceramic Architects.
oh, okay. All right. So,อาจารย์ has the latest one นะครับ Okay. So, this is example. Let's say the code and regulation that you have to be considerate, and you have to be considered in the design. Let's say like Dubai, they have external walls and roof that they have roof. The U factor have to zero cannot be lower than this. Okay, or walls. So each country they have their own standard. Okay. So this is the local regulation that the designer and the architect have to know. Okay, this one will impact to the design criteria. Let's say this building, the building orientation is important also. If the load, if the side of the building, the larger side of the building in the they hit to the load. Let's say for the west, you see in the western, in the afternoon time, they have a heavily load on the sun. Okay, on the east side they have load in the morning. Okay, so this one is also impact to the load calculation. Zoning also, sometimes you can see in the building they have perimeter. This one is a perimeter around the buildings and the internal zone. So the load in each section and each zone is not the same. So the calculation of the load will be it will be up to the space and also the zoning also. Also as I said, they have a latitude, longitude, altitude. It's important for the statistic outdoor that you need to use. Okay, and local statistic analysis of the weather data. Today, กรมอุตุนิยม Meteorology of Thailand also have the latest one. You can buy the data, or they have a published the old one also can use also. and the ASHRAE fundamental handbooks, which has all the data all over the world, including in Thailand. Okay, so they will have the data like this. Okay, they have how many hours of the year that they have a temperature on this. Okay, Thailand will be, the graph will be on the right hand side, more and more on the right hand side. So the cooling load, you can see that they have a temperature that they used. Okay, maybe 0.4% that we use the highest temperature, let's say in Thailand. Okay, Bangkok 37. Okay, but when we doing the load calculation, we use this as a normal, is the 1%. Okay, 1%. Mean wet bulb. Yeah. Okay. So Thailand also have the information in the ASHRAE table. Okay. This is the information in Thailand for Thailand. Okay. The indoor design criteria will depends upon the comfort base. Okay, maybe you have ASHRAE, AIA, local codes, owner requirement, and this is a basic one that normally we use. Okay, the basic temperature and air movement that we use is like in summer we use the 24 to 26 degrees Celsius. In winter we have 21 to 23 degrees Celsius. The air velocity in summer is less than 0.25 meter per sec. In the winter is less than 0.15 meter per sec. And relative humidity in the summer is about 40 to 50%. And tolerate to 65. Okay, in winter is around 25 to 30. Okay, this one you also can see the ASHRAE comfort zone that I have shown in previous slides. Okay, indoor air quality, so we have to treat it because the air, how to treat the air contaminants and outdoor ventilation rate as per the ASHRAE standard 62.1. Since we have the pandemic on the COVID-19. So ASHRAE also have launched the updated on the ASHRAE standard 62.1. Actually, you can download for free up to about June. Okay, so you can go to the website of the ASHRAE, so you can download and use that. Okay, and also the design parameter is the sound level of the buildings also. Okay. So for me, in conclusion, that you need to discuss with the M&E designer and the green consultant to ensure that you have designed it properly. Okay. So in the green building rating system, I think Dr. Ashrawan also has been mentioned many times. Okay. So like the most popular is LEED is the U.S. Green Building Council, which is run by the USGBC. Okay, they are rating the building. Okay, for Japan, they call it CASP. Okay, Thailand we also have, we call TGBI 3. Okay, Singapore we have BCA Green Mark. Okay, and also the German they have DGNB. So when you are designing or doing the load calculation or doing the energy analysis, have to in accordance to this rating also that you have discussed with the owner. Okay, so I think I stop for now. So 10 minutes later we can continue.
Yes,ค่ะ we come back at 10:40 ค่ะ students ขอบคุณค่ะ